Today we're going to be looking at factoring. We're going to begin with a quadratic trinomial with a coefficient of 1 in front of the x squared, and we're going to look how to break it down and factor it. Just for a little review, a couple lessons ago we looked at how to multiply two binomials. To multiply two binomials, we use something called FOIL, which leads us through the distributive property twice. So first we're going to multiply the x times each term in the second binomial. First we have x times x, which is x squared. Then we have x times negative x, which is negative 6x. Now we take the second term, which is a positive 3, and we're going to do the distributive property with it and multiply it times both terms in the second binomial. So 3 times x is 3x, and 3 times negative 6 is negative 18. Many times when this happens, in the center you're going to find like terms. Like terms are terms where you have the same variable with the same exponents. So in the end we need to combine them. So in this one we have x squared, and we combined a negative 6x and a positive 3x. That is a negative 3x, and then we have minus 18. So that's a review on FOIL. Now what we're going to do today is we're going to actually start here with the trinomial, and we're going to go back to the two binomials. So we're going to be doing FOIL in reverse. We call it sometimes reverse FOIL. So let's look and see how this works. Here we have our quadratic trinomial. We have three terms. The leading coefficient is a 1. There's a 1 in front of the x squared. Now what we're going to do first is we're going to look for, now when you have this in standard form, you always have the x squared term first, and then you order them from highest exponent to lowest exponent. So this one is in standard form. The term in front of the x squared is called the a term. The term in front of the x is called the b term, and the one at the end that is the constant is called the c term. So I'll be referring to a, b, and c, and you will know what those letters refer to. What we want to do is we're going to look at this c term, which is a positive 8, and we're going to find factor pairs, numbers that multiply together to get 8, and we're going to list them. I can think of 1 times 8 and 2 times 4. Once you think of those, now you want to look at the pairs that you just came up with and find a pair that has a sum of the b term. Now the b term in this one is 6. So 1 plus 8 is 9, so that's not the right one. 2 plus 4 is 6. This is what we wanted. We wanted the sum of the b term, which is 6. So we found factor pairs that multiply to get the c term of 8 and add together to get the b term of 6. Once you find those two numbers, now you're going to construct two binomials, and I already have the beginning of it here on the board. And since it's a positive 2, our first binomial is going to be x plus 2, and our second was 4, so in our second binomial it's going to be x plus 4. Now to show that this works, we're going to FOIL it and show you that we can go back to where we started. X times x is x squared. X times 4 is 4x. 2 times x is 2x. And 2 times 4 is 8. And when we combine these center terms, we get x squared plus 6x plus 8, which is exactly the trinomial that we began with. So this is called reverse FOIL. We take something and factor it out. So the key is to find factor pairs that equal the c term that have a sum or add together to get the b term. Slides here. Let's look at another example. Okay, first you're always going to look at the c term, which is 16, and you think of factor pairs for 16. I think of 1 and 16. It's divisible by 2. That would be 2 times 8. It's divisible by 4. That would be 4 times 4. And now I want to have a sum. Notice that the sign in front of the 10 is a negative. So this time when I add them together, I want to have a sum of negative 10. When I look at these pairs, I see a 2 and an 8. If they were both negative, if it was a negative 2 and a negative 8, the sum would be a negative 10, which is what we want it to be, the B term. If you multiply a negative 2 times a negative 8, you get a positive 16. So this is the pair that we're looking for. So when we take these and we write them down, sorry I had an interruption right there, we'll go back to this. I'm not sure where I left off. We have the factor pairs that we found of negative 2 and negative 8. So this time when we write our two binomials, it's going to be x minus 2, since it was a negative 2, and x minus 8, because of the negative 8. Now again, let's check this with FOIL. When you go x times x, you get x squared. X times negative 8 is negative 8x. Negative 2 times x is negative 2x. And negative 2 times negative 8 is a positive 16. When you add your center terms, you're going to get that negative 10x. So we have the same thing that we started out with, the same trinomial that we began with. So we're doing reverse FOIL. We're taking something that's been FOILed and we're undoing it. Here's another example. Always start with the C term, which is 42. Think of factor pairs for 42. 1 times 42 is divisible by 2. That would be 21. It's divisible by 3, and that would be 14. I'll do my math here in my head. It's not divisible by 5. It is divisible by 6. 6 times 7. So there's our factor pairs for 42. We want a pair that adds together to get a positive 13. So when I look at this pair right here, 6 and 7, and if I have both of them positive, they would add together to get that positive 13 that we're looking for. But they multiply to get the 42. So to make our two binomials, we have x plus 6 and x plus 7. If we do our FOIL to check it, x times x is x squared. X times 7x. 6 times x, 6x. And 6 times 7 is 42. And when we add these beginning middle terms, we get our 13x. So it does check out with what we were doing. In our next example, this time we have a negative 20 as our C term. So obviously one of these terms is going to have to be negative, because when you multiply and you want a negative, you have to have one negative. So first let's just think of the pairs 1 and 20. Then I have 2 and 10 and 4 and 5. Now in front of this B term we have a positive 1. So we want the terms to add to get a positive 1. Well, 4 and 5 are 1 apart. I want it to be a positive 1, so if I have the 5 is positive and the 4 is negative, those add together to get the positive 1 for our B term, and they multiply to get the negative 20 for our C term. So this time when we write our binomials, we have x minus 4 and x plus 5. In our next example, we have negative 18. We always start with a C term. We think of factor pairs 1 and 18, 2 and 9, 3 and 6. We want them to add together to get a positive 7, so we want the numbers to be 7 apart. Here is 2 and 9, they're 7 apart. Again, we need one of them to be negative because they need to multiply to become a negative. Since we want a positive 7, I want my 9 to be positive and my 2 to be negative. Because when you add a negative 2 and a positive 9, that results in a positive 7. And when you multiply it, you get a negative 18. So our two binomials would be x minus 2 and x plus 9. In our next example, we have a negative 24. So we think of factor pairs for 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. We want them to be 5 numbers apart because they want to add together to get a negative 5. So 3 and 8 are 5 apart. If I have a negative 8 and a positive 3, that would add together to get a negative 5, and they multiply to get a negative 24. So when I write my two binomials, it would be x plus 3 and x minus 8. And just as a note, when you're writing these two binomials, it doesn't matter the order. If you put the x minus 8 first and then the other binomial after it, when you FOIL it, it would still result in the same answer. So it doesn't matter which binomial you write first. Just so you'll know that. In our next example, we have a positive 8. So I think of factor pairs for 8, 1 and 8, 2 and 4. And I want them to result, when I add them, in a negative 6. If I make both the 2 and the 4 negative, and I add them together, that would result in a negative 6, and it multiplies to get a positive 8. So my binomials are x minus 2 and x minus 4. So I hope that helps with factoring with quadratic trinomials where the leading coefficient is 1.